Alright, so in this video we're going to talk a little bit about frequency responses. Now, if you went back and watched those videos, you've got a pretty good understanding of that. And if you've watched those videos on acoustics, you've probably got a really good understanding of that. So basically, let's just take a little quick look at frequency responses and what kind of issues we might be dealing with. Alright, the first thing I want to address is when they start talking about a frequency response of a microphone, that I'll tell you flat out that I think that you should have as flat a response as possible. If you went back and looked at the videos that I've showed you on equalization, shaping the spectral content and noise and distortion, shaping saturations, that you'll have a pretty good understanding that you can shape that frequency response however you want once you've got the capture done. So as flat a response as possible, in my humble opinion, is the best approach. Now, there can be some issues with that because sometimes you might be using some certain type of microphone to capture drum toms or your drum set or certain drums, and using a microphone that has a certain frequency response that's fairly, that's complementary for the most part to that drum, so that, it's capturing the frequencies that it produces fairly well with the frequency response that the drum is producing, or the frequencies it's producing, that microphone has a frequency response that captures them well. That can be a huge argument. But sometimes you'll get people, they want all these microphones that have all these different frequency responses because it colors the sound. So, not only you're talking about distortion, saturation, but also frequency responses as far as coloring the sound, which means that you're basically allowing the microphone that has got a set EQ on it to be used on any vocalist or any instrument you're using. Well, you obviously understand that's not going to work anyway. Otherwise, there wouldn't be a bunch of microphones. There wouldn't be a bunch of EQs, or different types of EQs to try to work on the spectral content of whatever you've captured. So obviously that, there's issues there. But my approach and the way that I try to tell people is as flat a frequency response as possible. That way that you can sculpt that the way you want. That way you can use that same microphone to capture different instruments and then sculpt the actual frequency content later to best be complementary for that instrument. And as that instrument starts getting mixed in with other instruments, that you might do more spectral content shaping on that instrument so that it's more complementary to the mix. And that sounds like a mouthful, but if you've watched all those videos that I've pointed you out to watch, that you should have a pretty good understanding of that anyway. So, basically, when we're talking about frequency responses, when we're looking at a frequency response here, what exactly are we looking at? Well, we're basically looking at, we've got this frequency response that, is going to show us, exactly what it's capturing. So it sends out, like a sweep, from low end to high end, and what decibel level it's capturing it. So capturing it at. So you can see immediately on this one that it's got a much lower sensitivity, the lower frequencies, and it's got a much higher sensitivity to the higher frequencies, which is going to shape whatever sound, like me speaking into this microphone, that, that sound coming through there is going to, it's going to, be more sensitive to those parts of my voice that you're hearing, and you're going to hear them louder. These lower parts are not, so there's a prime example why I'm doing these videos, that I've boosted the bass end up so that my voice sounds a little bit more professional, so that it wasn't all high and tinny, because it just wasn't flying. So if you look at a frequency response like that, you're seeing it's fairly level, and you're getting these resonances up here, and those just have to be taken into consideration. So, that's the first thing we got to look at. So how do we kind of look at that? So we already understand that like a sweep is going to, a frequency sweep, like a tone generator, is going to, into the microphone, is going to give us this frequency response. A frequency response diagram plots the microphone's sensitivity in decibels over a range of frequencies. So it's typically between 20 hertz and 20 kilohertz, the actual range of human hearing. So basically, that's a real simple concept to understand. And so the understanding of that is, there's can be a whole lot of argument there, but anytime that it's giving you some different type of frequency response that's not just a flat frequency response all the way across, and it's getting more looking like this instead of just flat all the way across, is that it's going to color the sound. So you're going to have to look at whatever instrument you're working with, and the frequencies that are going to be in that instrument and in that performance to see if that microphone is going to capture that well, or if it's going to attenuate or boost certain areas in the frequency realm, that it might cause an issue with that. And basically it's that simple. And sometimes you'll get a microphone that you want to use because it has a frequency response that's really complementary to the instrument you're working on or the drum you're working on, and you find you don't have to fuss with it too much because of the frequency response. Once you get the capture done, that you're not having to fuss with the EQ too much, which nowadays isn't very likely, but sometimes it might work real well, but I've found a lot of times I'm messing with EQ anyway, so I want a nice flat response. The other thing is when we're looking at frequency responses, what do we get? Okay, so we're looking at a frequency response on a microphone we're buying. We're getting to something that says 30 hertz to 16 kilohertz, plus or minus 3 dB. Now, that is going to say over that range, it can be plus or minus 3 dB. So it can be going up and down all over the place here, but it's not very specific. So it's really hard to, if that's not a real accurate analysis. But, you can kind of get, a ballpark figure of it sometimes. But if it starts saying like plus or minus 10, 15, 20 dB, you're going to have an issue if you have no idea where in that range that those fluctuations are at. Does that make sense? So, the understanding of that is to get, a graph of that. Does that make sense? So that the diagram is giving you a pretty good understanding of what that sweep read back to you, so that you have some understanding what the decibel levels, how sensitive. So down here in the lower end that this is really, not, it's very insensitive to that, and it's not picking it up. Up here, it's real sensitive to it. So it's, you might be careful up here because it might be boosting a lot of frequency content that you don't want boosted there. Does that make sense? And it's about that simple. The other thing that we want to talk about is, some programs that might help. There's a program here called REW, and you can download this for free. And you can sit here and look at the actual frequency response that you're getting from your microphone, measure it yourself. And you can see the frequencies across here and the decibel levels, so that you can get some kind of understanding where you're getting spikes and drops, attenuations and boosts in your frequency spectrum, in case that might be an issue. On this one, it's dropping down here, at, almost, 9K, all of a sudden it just drops. Well, that's just definitely going to be an issue, isn't it? If you're trying to catch some sparkle, and some high end, you're going to have a problem with that. There's no doubt about it. The other thing about this is not only can you pull in other impulse responses and frequency responses to look at, you can actually, besides just taking measurements to look at it, you can import frequency responses, import impedance measurements, and import impulse responses, so that you can, you do some analysis on your own of frequency responses, impulse responses, everything else related to your microphone. So what else should we address? Okay, first of all, let's reiterate, and then, let's just see, because basically, with a sine sweep, that basically you understand, I hope you should understand what a sine sweep is, that it's going to start a signal down here at 20 kilohertz, and then it's going to, do that across the spectrum, and then it's going to read how the microphone captured that, correct? So we're just reiterating. And as it swept through that spectrum up to the high end from the low end, that these are the readings that it got. So that, it didn't capture it very well down here on the lower end. Up here in the higher end, it captured it real well, and you can see the decibel levels that it captured at. So you can see how well it's capturing those frequencies as it goes through that frequency sweep. So that's real easy to understand. So, and I think we've addressed most of the issues of why that would be pertinent. And, you know, I can't think of anything else right at this moment that we should address because it's a very simple concept. And when we go to look at a microphone, that we're looking for this frequency response, we're having some idea if it's a general use microphone, if it's going to be used on drums and what their frequency content might be and their timbres. It's going to be used on a saxophone or a vocalist or a choir or, you know, whatever you're trying to capture, to have a pretty good understanding of the frequency, you know, what kind of a frequency realm it's going to, you know, going to capture, you know, how wide of a band of frequency you're trying to capture with that microphone. So you have a better understanding of, you know, what kind of frequency response you're going to need if you're going to be working with a microphone that has this response, something like this, that it's pretty obvious this mic isn't very good for trying to capture low end, you know, low end material. Whereas a microphone like this is pretty good. It starts dropping way down here a little bit, you know, down getting closer to 20 hertz. But, you know, it's pretty flat and it boosts a little bit up here. That might cause a little bit of an issue, but probably not too bad. And it's fairly flat response, which is a good general use. And that can be debatable depending on who you talk to. Because if you're relying on the microphone to do all your work as far as your EQ work and those kind of things related to the frequency content of your capture, then you're going to want to, you know, be way more attuned to what the frequency response is. The other thing is that, you know, without understanding, we got a pretty good understanding of that, and we'll probably address that some more, but I think we're pretty good to go. The other thing to understand is proximity. As the microphone gets closer, you got this frequency response, but as you move the microphone closer or farther away, or that its geometry and its angle to the instrument or what you're trying to capture can affect the frequency response. And it's very doubtful that you're going to get 500 different frequency responses from the microphone that you buy to know exactly that, you know, what the frequency response is in every position possible. So you have to work from what they give you and then, you know, make some determinations and understanding that it's when it's moving closer or moving farther away, or the angle is changing to from where the capture, you know, from what the, you know, the instrument, where the instrument is you're capturing, where the microphone is positioned to that, can change the frequency response of the capture. So just keep that in mind. So I think we've covered that, just the basics of it fairly well. So we understand what a frequency response is. We understand what they're trying to capture in the microphone. We understand what this means, and we understand how that might be pertinent and what kind of applications, you know, that we're going to use that microphone on is going to very much depend on what we want for a frequency response. Does that make sense? And I think we covered that fairly well. We can get into that really in depth, but we're not going to at this moment. We just kind of wanted to cover that so we have an understanding of what we're looking at and why those things might be important, because the saxophone, you've got this microphone that captures the saxophone real well because its frequency response is very complementary to that saxophone. Or you've got a frequency response on this microphone that's very complementary to this tom set or this drum set or this specific, you know, snare. And you use this microphone to capture that snare because the frequency response is very complementary to what that snare is going to produce in the frequency domain. And try to keep it that simple in your head. And, you know, there's lots, you can debate and argue that till doomsday which way to approach it. But my recommendation is that on some things, if you've got like just for toms or just for snares, sometimes you might want to get a mic that's got a frequency response that's real complementary to those that you don't have to fuss with. But a lot of times you want a microphone that's got a flatter response as possible so that you can shape it how you want later in the mix. Because, as you know, if you've ever done any mixing, there's a good chance you're going to have to pull out the EQ no matter what you do. So, you know, I mean, you might as well get it in your head. You're going to have to do something to it anyway. But I think we covered most of those issues pretty well. And when someone says frequency response, I think that you should have a pretty good understanding what that means and what to look for. You're looking for this diagram, or you're looking for something that's telling you about what the frequency response is, and it should be very clear. So, Let's move on to the next subject.